I am in Palo Alto, which is the kind of the center of Silicon Valley in California or San Francisco Bay Area. So most of what tech we use today, it comes within 30 miles of where I'm sitting. Google, Facebook, Cisco, Zoom, Yahoo, anything you can think of, or almost anything that has come in the world from technology perspective has come from this area. And a lot of people in the world are now trying to copy the model on how Silicon Valley creates this startups which create new products which get adopted by people, so that creates jobs, makes life better for people, and also grows the economy. And what I'm going to share with you today is what I've learned over the years by working in different companies, my own or other bigger companies. How do you create something new using technology? What are the challenges? And is there a method you can follow? I think this session is about social good. And you can use these methods to build something that is for social good. So let me share my screen. So I think it's a buzzword now. Everybody talks about innovation. And there's a lot of discussion in academia on what that is. Is it a new feature in a product? It has to be something brand new. A lot of people have to use it. What is it? But all that doesn't matter. What matters is, are you creating something new that people are finding valuable? And you can broadly classify that into two categories, how you create something new. One is technology-led and one is user-led. So technology-led is where the big changes come from. That's the science, universities. For example, internet, which how we are having this meeting is technology-led. No company or people didn't sit and think, oh, let me create the internet. It was the scientists, engineers working to create something that was more technical in nature, exploration. Same thing with transistor, semiconductor. It was created by William Shockley because he was just interested in it, and that ended up creating many industries. Nothing would work today without semiconductors or nothing electronic. And everything you see around you today was innovation at some point. So, for example, the day of the week, somebody came up with that idea. Let's have a week and let's call it Monday, Tuesday, Wednesday. So even that was innovation at some point, but now we take it for granted. The chair I'm sitting at was innovation. Glass was innovation. So with time, it becomes the norm. So innovation is new at the time, but things that get adopted become part of life, and that's what you want generally when you're creating new things. So this presentation is mainly about creating user-led new products or using technology to create solve user problems. And anytime you have a question, please stop me. I'm happy. It's better you ask during, otherwise you won't remember the question. So there are three ways I'm still using to create new products or new things in the world. First, I call break the Rubik's Cube, or BRC. So you create, let's say you take a lot of Rubik's Cubes, break them, and create something that's all yellow or one color. So the whole itself is new, but none of the parts are new. And that is the basic idea. You pick technologies from different places, put them together, and create a new product. The first iPhone had nothing new in it. All the technologies that were in it existed before in different places. A microprocessor, multi-touch, memory on the phone was 16 gig. Everything existed before. And here I have an example of a device that things have changed since then. But at some point, Microsoft Kinect was the device that was fastest adopted device in the world. It sold, I forget, few million of these devices in a few days. And what was new about it? And if you don't know what that is, it attaches to an Xbox, um, and then it has gesture control, and you can play games. It recognizes your movements. So it had an RGB camera that came from the Hubble telescope. So that technology was previously used in the telescope. The RGB camera helps you, um, see the depth. Microphone array. They existed in conference rooms before, and they took that and put that in the product. Infrared projector. So this is to see things at night. This was used in military tanks. Video recorder. It was used in video before, on recording videos. Motor. It has a motor. It existed in cars and many other places. And then you combine all those technologies are in this device. So you created a brand new product with a brand new use case or ability to play video games without the remote control. And that created, in turn, more games, on and on. So that is the idea, where you create something new, which comes from combining a lot of existing things. So a lot of engineers don't like this because it's not original, but practically, this is how most of the technology development works, where you take a lot of, I should say, new product development. You take existing things, put them together in a novel way, and create something new. Okay, next is copy, paste, edit, where you take one thing and combine with another, and you create something new. And I think the best example of that is camera phone. You take the camera, combine that with the phone, and you have camera phone. Now imagine like life without your phone today, smartphone, or they're like multi-billion-dollar industries built around just because there's a camera in the phone. There's Instagram, TikTok, Facebook, and I don't know. That's so it just having these two things together has added how many, I think, hundreds and billions of dollars to the global economy and created a lot of jobs. And it's a very simple idea. You combine camera with the phone. Another example is taking one, like motors. My Razor has electric motors in it, and it works better. So that's another example how then companies can charge more for this product, and it's innovative. Okay, who would have thought you can put a motor in the Razor? Display technologies. Now you have them everywhere. The car seat in the back have now displays for kids to watch movies. Airplane seats have displays. So if you add a display to something, like in old days, the thermostat didn't have a display. So now thermostat has a display, so you can see for air conditioners, so you can see what the temperature is and change things, etc. Wireless technology. You may have heard of IoT, or Internet of Things. All that is adding connectivity to devices or things that were not connected before. So, for example, cars are connected now. At home, my light bulb is connected to the internet. So I can, change the color. It automatically turns on when I go home. It automatically switches off when I leave. So wireless technologies is another thing you can add to something and create something new. And if you think about it, we are all product of copy paste edit. So when children are born, it's the DNA of two people that's combined and edited, and that's how you get a new child, something brand new that just comes from two different places. Okay, and now I'm going to third one. Any questions on second? Okay, third is inverted Rogers model. So Everett Rogers is one of my, well, he's no longer alive, but he was one of my heroes. He came up with this uh, S curve. It's commonly known as S curve, where you study. He was the first person to study how anything new gets adopted. Like, how is it that in English, when people in the US now speak, younger ones, they every second sentence or they use the word like. How did that happen? So he studied anything that's new and how it got adopted. And I saw this pattern. It goes like, as initially there's small adoption, and then it rises very fast and it plateaus at some point. So he saw there are 5 common attributes for anything gets adopted. So if we know that there are 5 things that make things adopted, why don't use that to create products or new products, uh, keeping those 5 attributes in mind, so then you have much higher chance of things getting adopted. And these 5 things are, first is relative advantage. So what you are creating, how is that better than what exists in the market? I don't know how many of you know iPod. It was new at some point, which was a device where you could listen to, I don't know, thousands of songs in your pocket. And the relative advantage at that time was, and it came out 20 years ago, before iPhone. Relative advantage was you had 1,000 songs in your pocket, and you didn't have to carry CD player or Walkman or all the previous stuff. You were limited to 10 songs, and now you had 1,000 songs. The relative advantage is, are you creating something that's better than what exists? It doesn't have to be perfect. It just has to be better than what exists. Then it's interoperability. So what you are creating, does it work with what exists? So that's backward interoperability, and also forward interoperability. So for example, with iPod, the backward interoperability was you could convert your old songs you owned on a CD to a digital format, and then forward was you could buy songs directly from iTunes. And how innovation works, and that model no longer, for the most part, people are now moving to subscription based models. So even that has evolved further. But at that time, 20 years ago, iPod had backward and forward interoperability. You also have to think about mental model operability. So does it work with the new product you're thinking about? Does it work with how people think about the world? Or is it a brand? People have to change the way how they think. And if they have to change the way how they think, then it'll be hard to sell it to people. So a good example of mental model is, let's say, I don't know, if somebody thinks there's no climate change happening, that's their mental model. It'll be hard to sell them, a green energy product. So you have to understand what is the current mental model people have and how it works with that. So it's not only the the physical aspects of the product, but also the mental aspects of the product. Third is simplicity. Simple things generally they're easier to understand, so they get adopted much faster and wider. Here, Leonardo da Vinci, is one of the great artists. He says simplicity is the ultimate sophistication. It's much harder to simplify things than to create something complex. And continuing with the iPod example, their user interface was famously simple. Everybody got it, and you didn't need to read a manual to figure it out. And then it's trialability. Things make the product easier to try, because if people cannot try it, then they're not going to use it or buy it. Or if it takes too long to try, the adoption is much slower. I used to work for Siemens, which is a German conglomerate, and the product I was working on was the wireless base stations. So that's how the your cell phone signals travels to the internet or to other people, because when they bought the product, it had to work with the existing network. So to try it was like a year. So everything, we had the product ready, but for them to buy it, it was 18-month sales cycle. But you have to make trialability easier. With Apple, they launched Apple's retail stores in the US first, and now they are global. So people just can come and try the product. And final one is observability. So things that are highly observable get adopted much faster. So somehow before Apple came out with the iPod, all the headphones were black. They just created white headphones. So everybody knew on the train, people jogging, if the headphone was white, then people knew that it was iPod. So you have to think about how do you make the product observable so people see it. And fashion companies do that really well. All the handbags have logo, so it's highly observable. So that's what I call IRM, inverted Rogers model. So the model is how things get adopted. If you invert it, then you can use those attributes to create new products. So these are the three ways you can use technology to create new products. And then any questions so far? So now we see, okay, there are these three ways you can use technology to create new products, solve user problems. How do you execute on that? So first thing you have to figure out is there a market for something like this? You may create something that's valuable, but people don't want to pay for it. And maybe only, let's say, 1,000 people want it. The market is not big enough. How are you going to distribute the product? It may be the math doesn't work, because meaning today the biggest problem the startups have in the US or Silicon Valley is customer acquisition cost. It just costs so much money to acquire customers because the field is so crowded. You have to spend money in marketing, advertising. And if it's a physical product you sell through a retailer, they keep 30 to 40% of revenue. So how do you to figure that out, understand the value chain? What is the market feasibility of the product? Then technology feasibility. This is also a common mistake I see, is when something works for an engineer doesn't really mean it works for an average person. So going back to iPhone, or they use a technology, and now all iPhones use it. It's called capacitive touch. So you can use your finger to do things. There's another technology called resistive touch. You may see that in retail stores. You have to use a pen to use the touchpad. So when there were other products before iPhone that used capacitive touch, but there was a lag or latency. So they launched it because it works for an engineer, but the customers hated that few seconds of lag. So no, it didn't get adopted. So then eventually they made it work, and now everybody uses capacitive touch. Also, you have to see, can you source all the parts? So for example, if you're making something physical, somebody has to make the parts. If there are a lot of other people want it, then you can't get it. So a recent example is the whole supply chain of cars was kind of stopped because a car costs $50,000, but the manufacturing had to stop because a $2 chip was missing, because car companies buy semiconductors and they are not top of the list in companies that make semiconductors, TSMC, because phone, TV, all these other customers come first because they buy more. So you have to figure out technology feasibility as well, in addition to market feasibility. Then third is rapid prototyping. So this is also a common mistake people make, is they think prototype is basically inferior version of the product. But in essence, prototype, you're testing people's mental model and feasibility of the product. So for example, the picture you see here is the first multi-sensor consumer fitness device, which my team created at National Semiconductor. It's in the Computer History Museum in Mountain View. This is before there was Apple Watch, Fitbit, or any of those devices. So I wanted to test, okay, are people going to wear something on their hand? Does it of that size? And how do they feel about it? So instead of before we built or made any electronics that go inside the device, we just created these bracelets and worked with the Stanford Design School and gave them to students to wear them. How do they feel? Like, if they don't find it cool enough, or it's too odd, that it doesn't feel good on the skin, then no amount of technology will help. So that's idea of rapid prototyping. You're trying to understand, like breaking the problems into smaller parts and using prototyping to understand those parts. And rapid meaning you have to do it fast. So you learn something, then you go back, do it again. With this, once it worked, then we put some electronics in it, but this is actually a good, interesting example. So we developed this algorithm that measures your, how many miles you're walking or how many steps you're taking based on movement of your hand. And it was early days, so we weren't that accurate. But we found that if you undercount, people were upset and they didn't want to use it. But if you overcounted, they were not so upset. They didn't give up on it. So so these minor details matter a lot. It'll take time to get it accurate. So then you compensate by doing over rather than under. So these kind of things you learn by prototyping. And the last one is customer validation. That's more in terms of B2B. I think customer validation, you get consumer products, you just launch it and you figure it out. But B2B, somebody has to agree and take the risk with you. A common mistake people make is You create something, you take it to the customer, and they say, "Yeah, I love it," and you go back all excited, and the customer liked it, but they haven't committed anything, they haven't taken any risk, and they give you feedback, add this, do that, and then you go back 6 months later, spend all that money, and they say, "Yeah, that's good, now add this and that," and then you come back. So the cycle continues. You still don't know if they are actually interested, or they're just being polite, or they have any intention of using it. So you have, if the customer commits or takes some risks with you, that is validation. Somebody telling you they like it is not validation. Okay, now the final section is challenges. But before I get there, any questions on uh, the second part? So now and I've seen them at in various degrees, all the 5 challenges I'm going to share. Um, it, I think I lost count how many new products I've developed, but in all of them, I've seen these challenges. First one is, how do you measure progress? So, in a public company, or in any, um, even in your organization, people generally have goals or KPIs, and you, at the end of the quarter, in public companies, every 90 days you have to deliver, and generally people focus on that. So when I was at T-Mobile, I was managing a $600 million business, and every 3 months I had to see what was the revenue, cost, etc. And it's it didn't really, if it was good, me or people generally didn't care. Okay, we met the target, awesome. If it was bad, okay, why didn't we meet the target? Uh, these were the reasons, and you move on and try to do better next quarter. But what happens is, people, you know, when they do that, they don't question why. Am I measuring the right things? Am I making progress? Because when it's something new, it's very different. You don't know if you are going in the right direction. You may be measuring progress. Let's say, you're measuring miles walked going north, but you don't know if it's north. So it becomes very important how you set up the KPIs in a startup, or when anything new you're developing, doesn't matter startup or not. The metrics have to make you think. Normally the metrics kind of eliminate thinking. Is it good or bad? That's it, move on. But think of metrics that make you think. Right team. I think this is, of everything, this is the hardest thing to do, because business, nonprofits, countries, it's all about getting the right people aligned towards the same goal, and having them work with each other. People, and that sounds very easy, but it's hard to do. Um, what is the right team? Like, how do you figure out? Because we are talking about technology, you can hire generalists, you can hire specialists. What is the right mix? How many people do you want with a lot of experience? How many people with no experience? How many people from the same industry? How many people from different industry? So figuring out what the right team is hard. Um, and then you have to know, uh, what is the balance of um, people trying to do, um, like, innovating, and when to give up. Like, some people never want to give up, but at times you have to give up because it's not going in the right direction. So that's always been a challenge. And these 5 things I'm sharing, I don't have the answers. You'll have to find your own answer. It's very contextual, but eventually you find ways to make it work. Only then you succeed. If you don't have the right team, no matter what the technology is, none of it will work. Most important, what I found worked is the chemistry. If people respect each other uh, position, and they don't have to like each other, they have to respect each other, then it works. Influencing the ecosystem, that's hard for new companies. How do you make everybody align with the uh, towards the same goal? And you are small, ecosystem is not gonna work in your favor when you're small. So for example, let's say the um, making this, again, the wearable device example, you have to align. We weren't going to make a consumer device. We were creating a market for it. Like, the idea was 2 years from now, this will be we can create market for that. So you have to source all the parts. You have to find somebody who's willing to work with you, a distribution partner. Then for the you have to get the right designers. You have to have some kind of support system, software. Like, there's so many things have to work together. How do you move the entire ecosystem to your will, or what you want to do? It's easier if you're market leader like Apple, Disney. They decide actually what happens to the ecosystem. But if you're small, it's much harder. Okay, what is the right timing? That's another really hard thing to figure out. I think LED bulbs, the example I like is LED bulbs. They've been around since 1965. Some professor created that, and they've been around since then. And now they're more widely adopted. But like 20 years ago, or 15 years ago, their market share was 10%. So from 65 to, let's say, 2005, in 40 years, 10%. Uh, you don't know when the timing, uh, if you get the timing right. Technology may be ready, market market is feasible, technology is ready, you've done the prototyping, you have the validation with the customer, but it may not be widely adopted because the just timing is not right. Another good example of that is things like, you may not remember, but 99 was the big dot-com crash in the US. There were a lot of companies which went to market and went IPO and crashed. And everybody made fun of them afterwards. Webvan is the commonly cited example, because they were delivering groceries. And everybody thought after the fact, oh, that was stupid. And now they're like Instacart, is a very successful company. Amazon is delivering groceries. Now it's a common thing. But 20 years ago, the apps weren't there. The internet speed was slow. So the timing wasn't right. Objective thinking. I think now that I'm going through it, everything seems really hard. I said, this is the hardest thing. Then I look at the next one. Oh no, this is the hardest thing. So think of all 5 things I shared. This is probably the hardest. How do you think objectively? So, for example, what is thinking? Like, where does thinking come from? Thinking comes from memory. You can't think without memory. And what is memory? Memory is all past. Memory is, some of your past experiences. So all your thinking comes from your past. How do you create anything new based on all your past? So it's really hard to do, but you have to work at it. I think some of the what helped me a lot was reading Krishnamurti. If you read any Krishnamurti, it gets into depth with that, into what thinking is, how thinking works, and how do you become more objective in your thinking. Okay, I think that's the end.
Okay.
Yeah.
I found this on the web for if you read any Krishnamurti legal.
Okay, that was my Siri on the laptop talking. So, despite all the challenges, it's a lot of fun creating new things. That's how things move forward. Without innovation, we would still be, hunter-gatherer, living in, I don't know, somewhere in the jungle. So it's for progress, innovation is necessary. That's how the world moves forward. Okay, that's the end.